Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have did a numerical which was based on Boyle's law, and now we are going to do the another numerical which is based on Boyle's law but with a different question and different kind of the requirement. So let us do it. So friends, as mentioned on the screen, there is a question which is based on Boyle's law. So first of all, let us read it and let us see whether it is asking about Boyle's law or not. So the thing is, they have given that a balloon has a volume of that is 0.6 cubic meter and of hydrogen at normal atmospheric pressure. And at same temperature, if the volume is increased by 15%, then then we have to calculate the pressure surrounding the balloon. So by looking at this question, how can we analyze whether this numerical is asking about which of the laws, that is Boyle's law or Charles' law? That in this case, clearly we could see that they are asking about at same temperature. Means they have mentioned a thing about same temperature. That means the temperature is being constant, as well as the volume is also being provided, as well as the atmospheric pressure is also being mentioned in this case. So this indicates that we are talking about Boyle's law, and since it is Boyle's law, so it would be very much easy to calculate this thing. And the thing is, this is a different kind of question compared to the previous one, because what they are asking is, they have said that if the volume is increased by 15%, then what would be the pressure around the balloon? So this is what they are asking about. So the first thing that we are going to do is we are going to extract the data and let us see what is the answer that we could get. So the first thing that I am going to do is I am going to extract the data. So therefore, in the given data, what they have provided us is that 0.6 cubic meter of hydrogen gas is being given to us or is being provided to us. So this is the first volume that they have provided to us. So therefore, I could name this volume as V1. So therefore, this is V1. V1 is nothing but 0.6 cubic meter of hydrogen gas. And on the same, they have said that this volume is being maintained at a normal pressure. So in this case, the normal pressure, I would name it as P1. But what is normal pressure actually? So normal pressure is actually 1.01 into 10 raised to 5 Newton per meter square. So this is nothing but the normal pressure we are talking about. So therefore 1.01 into 10 raised to 5 Newton per meter square, that is Pascal, is the atmospheric pressure, normal atmospheric pressure. So this is the data that what I have got from the question, and this value I should know that it is 1.01325, but I have to 1.01 just for an instance to make it understand that this kind of numerical would be very much easy to solve. And now talking about the next one is what they have said, that the temperature is being constant, that is at the same temperature, and if the volume is increased by 15%, then we have to calculate the pressure surrounding the volume. So in this case, what they have mentioned is that the second volume, that is the volume V2, is being increased from its initial volume by 15%. So there is a formula that I could mention you so that it would be very much easy to calculate. Suppose if this percentage is a factor has been mentioned in the question, then how can we calculate the original value of the volume from the percentage? So what we are going to do is, suppose this is the original value that has been given, that is the V1, the initial volume is given as 0.6. So yes, I have written as 0.6. What I will do is, because the volume is being increased by 15%, 15% is being increasing out of 100%, suppose. So therefore 100 plus 15, which means total makes of 150 out of, yes, out of 100%. So therefore this is what I am going to do. I am dividing it by 100. So suppose now this would be very much easy to calculate, and let us see what is the answer that we could get for the volume V2 if 15% is being increased from the initial volume or initial volume which has a value of 0.6. So let us calculate it. So what we have got is 0.69, but yes, the unit will be in cubic meter. So this is the value of the volume which has been increased from 15% when the initial volume is being given as 0.6 cubic meter. this is the volume that we have finally got by reducing the question. And in this case, what they are asking is we have to calculate the pressure. So initial pressure is been given. So what we are going to do is we have to find out the final pressure which is surrounding the balloon. So again, the temperature is being kept constant. So basically, we are talking about Boyle's law. So we could say that according to Boyle's law, the formula that we have is nothing but P1 V1 is equals to P2 V2. So this is the formula that we have. And now what we are going to do is we are going to substitute the values in this formula and let us see what is the answer. So the P1 that they have provided to us is basically 1.01 into 10 raised to 5 Newton per meter square, which basically means Pascal itself. So I have mentioned here unit, but it is not necessary that you should mention unit. You should mention the unit at the last also. It will be fine. So the volume that they have provided us is 0.6 cubic meter. So that this is they have provided, and the pressure 2, which is something which we have to calculate. And talking about the next thing is the V2 that they have been provided to us is basically 0.69. So this is the thing that they have provided to us. And from this thing, what we are going to do is we are going to calculate what will be the value of P2. So I am going to rearrange it so as you could understand better, and there should be no mistake while doing or while solving this kind of numerical. So what I am going to do is I will substitute the values in a right proportion and in proper proportion so that it will be very much easy to understand. So this is the thing. So this is how I arrange the one, and let us see what is the answer we could get. So what we have got is we have got the value as 87826.0. So this is the value that we have got. But we could write it in Newton per meter square also. So I could arrange this value in the form of 10 raised to 5. So therefore this would indicate that if I do this thing, that is if I write in 10 raised to 5 factor, so 3, 4, 5, so I could write it as 0.878 into 10 raised to 5, that is Newton per meter square that they have provided to us, or I could write it as Pascal also. So this is the value of P2. So this is the value of P2, that is the pressure that we have calculated around the balloon or which is surrounding the balloon. So let us compare whether how the pressure has been increased or decreased in this case. So in this case, I would write in this way, that is the initial pressure that they have provided to us is basically 1.01 into 10 raised to 5 Pascal, and the volume which was given as V1 is equals to 0.6 cubic meter. And the next thing that I saw that the volume which is now being increased from 0.69. So by calculating the pressure, what we have got is we have got the pressure as 0.8 something 0.87 into 10 raised to 5. So this what clearly indicates is that basically if the volume is being increased, then suppose if the volume is being increased, now what happens is the pressure will be decreased, because volume and pressure both are inversely proportional to each other when we are talking about Boyle's law. So this is where the pressure was more compared to that of the P2, and here in this case the volume which was more, and in this case the which was 0.6, and now we could see that V2 is much more means it is greater than that of the V1. So it indicates that if the volume is been increasing, pressure would be decreasing, and hence it is following the Boyle's law. So this is how we could understand a particular numerical, not only by solving it but understanding it in a better way. So thank you friends for watching this video. I hope you have liked this video and you will share this video with your friends too. And yes, don't forget to subscribe Ekeeda channel. Thank you so much.